Alright class, this note sheet is actually kind of a review note sheet, so if you want to try doing it on your own before listening to the video, try as many as you can to see if you get it correct, because like everything on here you should know how to do because the quiz is tomorrow. Alright, so when you sketch these, again, I would like to see the parent graph. So the first thing you have to note is what kind of graph is this? This is a cube graph, so cube graphs look like this. Cubic, I should say. Alright, and then we have to figure out what's happening here. It's being stretched vertically, which means it's getting skinnier. It's moving to the right 1 and down 3. So my sketch should look something like this, where it's being pulled up faster and down faster. That would be what I would want to see. Okay, this is a cube root, which is the sideways cubic function. So it looks kind of like that. It reflects over the x-axis, so it's actually going to be going the other way. It's being compressed, which means it's getting closer to the origin or wherever it is, and it's moving right to. So 1, 2. It is reflected, and it's closer to the origin, so it looks like that. Okay. Next one, we have a square root. Parent of a square root function looks like this. It's just half a parabola. We are reflecting. Remember, when we're reflecting over the x-axis. It's not going to the left. It never will for these. And then we have it starting at -3, -2. And it's also being stretched. It means pulled up because it's a sideways one. So -3, -2. So here it is. Well, actually, it'll be pulled down because it's reflected. So this should look something like that. Okay. Alright, and then finally we have an absolute value graph, which has a parent that looks like a V. Okay, we have the point, it's going to be reflected. It's going to be compressed, which means it's going to be wider, and it's going to be at -2, -1. So that's right here. It's going to be the other way, and it's going to be compressed. So there we go. So that is those are the 4 sketches that you should have, and the parents that go with them, so I can compare them. Okay. Next, we're going to just list the steps that required to go from here to here. The first step, I always reflect over the x-axis. If there's a negative sign there, don't always do it, but if it's there, do that first. Next, we are going to stretch it vertically by 2. Then I'm going to move it 3 to the left, and finally I'm going to move it 6 down. Okay, and that's the answer for 5. Alright, now before I do 6 and 7, I just want to note the domain restrictions for these 2 pieces. F of x has to have values that are greater than or equal to 0. G of x are all real numbers because it's just a linear function. If I divide g of x over f of x, we get x minus 3 over the square root of x. In this case, I might say not to rationalize, so you can leave it like this. So if I tell you in the instructions don't rationalize, you can leave the square root down there. If I did tell you to rationalize, then you would do this. And you would get the square root of x times x minus 3 all over x. And that's kind of it. And regardless, so either of these are fine. That's not rationalizing, that is rationalizing. The domain restriction is that domain, hopefully you see that not only is it that x is greater than or equal to 0, but it actually can't be 0 either, because now there's a fraction, so it's just greater than 0. Okay, this one's an input function, so we're putting g into f, so this becomes the square root of x minus 3. There's no denominator, so we don't have to worry about that. There's no restrictions for the input, so we just have to figure out the restrictions of this. Well, this thing cannot be negative. So that means that x minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3 for the domain. So that is what my domain is, because of that final answer. Alright, same thing. This has no restriction. This you can rewrite as 10 over x. and we're sticking f into g. So that means where I see an x for g, we're putting f, so it becomes 10. So that equals 10 over 5x squared minus 20. To simplify, factor the bottom. We can take a 5 out of there, x squared minus 4. We can turn this into a 2 over 1, and then this factors to an x minus 2 and an x plus 2. Okay, so that's the final answer. The reason why I factored it was so I could look at my domain. I look at the input, there's no restriction for f of x, and I look at the final answer. For the final answer, we can't have zeros on the bottom of our fraction, so x cannot be the values of plus or minus 2, because that'll turn the denominator into 0. Alright, and then finally, or not finally, there's one after this, we have, let's turn things into inverses. So, first thing you do is switch the x and y, so this becomes x equals 3 root y plus 2. Next thing I'm going to do is divide by 3. Next thing I'm going to do is square both sides, because I need to get that y by itself. So I get x squared over 9 equals y plus 2. And finally I can say that y equals x squared over 9 minus 2. And then remember, since I gave it to you in function notation, the actual answer is f inverse of x is equal to x squared over 9 minus 2. Alright, so that's that one. This one we switch, x equals 6y cubed minus 10. Move the 10 over. X minus 10 is equal to 6y cubed. Divide by 6. X minus 10 divided by 6 equals y cubed. Now we have to take the cubed root, or for everything. Remember, you do the top and bottom separate. It's easier to think like that, so you know you have to rationalize. So we get y is equal to the third root of x minus 10 over the third root of 6 to the first. We can't have a third root on the bottom, so we need 2 more 6's, because that'll give us 3 of them under there and it'll cancel. So that means we're multiplying the top and bottom by 6 squared. Okay, and then from there, okay, so then we multiply that value in. This is 36, so we get y equals the third root of 36x minus 360, because remember 6 squared is 36. And that can be multiplied in all over just 6. But remember, I want it in inverse notation, so this is actually the answer. Remember to do that. Okay. And then finally, to verify, you have to remember, to verify these, you have to find f of g of x and g of f of x. And they both have to equal x, and they'll tell you that on the instructions. So, for f of g of x, we're taking f, and we're putting into f g of x, which is actually that, minus 14. So the first thing you have to do is break the 1/5 and the 5th. So you get 7 times, this is just x over 7 plus 2 minus 14. Distribute the distribute the 7 and get x plus 14 minus 14, which is just x. Over here now we're taking this one and putting the f into this one. So that means on top of this fraction we get a 7x to the 5th minus 14 all over 7 plus 2 all raised to the 1/5. You cannot do anything with that 1/5 yet. Remember, you can't distribute that. But you can simplify the inside. So we can divide everything by 7, and we get x to the 5th minus 2 plus 2. Again, this is the step people screw up. You cannot distribute the 1/5. 2 minus 2 is 0, so we get x to the 5th to the 1/5. Now you can cancel out the 1/5s, and you get x. So they are inverses. F of x and g of x are inverses. Okay, that is the review lesson. So keep working on the worksheets, and you have your quiz tomorrow.